All right, now I want to show you why this theorem holds. All right, so remember that this is the degree, right? This is the degree. This is the number of vertices that touch VI. And by the theorem that I introduced in the previous video, this is the number of two-edge walks from VI to VI. So this is number two-edge walks from VI to itself, to VI. Oops. Number of two-edge walks from VI to VI. All right, so let's start with this. Let's look at this graph we have here. What's the degree of V1? Right, this is, you could see that this is 1, 2, 3. That's 3. Right, the degree is 3. So now let's ask ourselves, how many two-edge walks are there from V1 to itself? So let me draw them. So we could go this way, but now to get back, we have to go back the same way. So a two-edge walk from V1 to, so it goes this way and then comes back. That's a two-edge walk. It goes down and then comes back. So one of the two-edge walks let's say from V1 to V1. I'll list them here. So one of them would be V1, V2, V1. That's a two-edge walk from V1 to V1. It goes out to V2 and then back to V1. Another two-edge walk would be this one. And this would be V1, V3, V1. And another two-edge walk would be this one. This would be V1, V4, V1. And so you can see that there are, in fact, 3 two-edge walks from V1 to V1. So the number of two-edge walks from a vertex to itself, that just counts going out on an edge and coming back. Going out on an edge and then coming back. And that's counting exactly the degree. Maybe we should look at one more. Let's look at the degree of, I don't know, which one do you want to look at? Oh, okay, V4. That sounds good. Good idea. The degree of V4, right? The degree of V4, well, let's see, you can see that it's 2, but you could also see that the number of two-edge walks, two-edge walks from V4 to V4, let me list them here. You've got V4, V1, V4, and V4, V3, V4. And so there's 2 of them. They are exactly the same thing. And so what does this mean for the matrix A squared? It means that down the diagonal, right, in A squared, down the diagonal is the degrees. So the degree of V1 is 3. The degree of V2 is 2. The degree of V3 is 3. And the degree of V4 is again 2. So there's the diagonal entries of our adjacency matrix, or of our adjacency matrix squared. Okay, so it's not the adjacency matrix. Adjacency matrix is all zeros and ones, right? But A squared is going to have more than that. It's not going to have just zeros and ones because we're talking the number of two-edge walks. All right, so maybe we should fill out the rest of the adjacency matrix. That seems like a good idea. So let's think of this again with the grid idea, with the way of thinking of it as a grid. So you've got V1, V2, V3, V4, V1, V2, V3, V4. All right, so this entry right here, this is going to be the number of two-edge walks from V1 to V2. So how many two-edge walks do we have from V1 to V2? Maybe I should redraw some of these. So how many two-edge walks do we have from V1 to V2? Let's see, you have 1 there, and that's it. Okay, so that's going to be a 1. Now V1, V2 is a 1, and because of symmetry, again, V2, V1, right, is going to be a 1 as well. Right, if the number of two-edge walks from V1 to V2 is the same as the number of two-edge walks from V2 to V1. Now, technically, they're not exactly the same. We wouldn't think of this walk, V1, V3, V2. This is not the same walk as V2, V3, V1. They're not the same walk because they're different sequences, because they have different order. But counting one of them counts the other. Okay. All right, so now let's look at this position here. This is the number of two-edge walks from V1 to V3. How many two-edge walks are there V1 to V3? There's 2 of them, right? Do you see that? You've got that one and that one. So that's 2. V1 to V4 two-edge walks. I think there's just one of them. All right, so V1, V3 was a 2, so V3, V1 is going to be a 2. And we got a 1 there as well. All right, V1, V4, so V4, V1. All right. Now, looking at this position here, that's the number of two-edge walks from V2 to V3. Two-edge walks from V2 to V3, there's just one of them. Right, it's just that one. One of them. So V2, V3, V3, V2. Okay, V2, V4. Number of two-edge walks from V2 to V4, you can see there are 2 of them. 1, 2. So 2, 4 is a 2, so 4, 2 is a 2. Okay, and we're almost done. So V3, V4, now looking at that entry, the number of two-edge walks from V3 to V4. So starting at V3 here, V3 to V4, looks like 1, just one of them. So 1 there, V3, V4, V4, V3 is a 1. And now going like this, and saying A squared, then I'm done.